potential for some severe weather tomorrow. Mainly, it's for portions of far northern Oklahoma, far northeastern Oklahoma, much of eastern Kansas, parts of far northwestern Missouri, and a very slim portion of Nebraska, far southeastern Nebraska. We do have a 10% tornado risk and a hatch 10% tornado risk in the similar areas. So basically, hatch basically means you have 2 plus as possible. Then we have a 50% hail risk, and the biggest risk in terms of percent is actually wind. It's actually a 30% wind risk. Really, the area that you have the hatch tornado risk, or the 10% tornado risk, I should say, will be the highest risk for all severe weather. It was a little bit controversial when this hatch came out. I'm not sure I believe it. I think they might downgrade it to a regular 10%. We'll have to see, though. The 10% tornado risk basically means that you have a 10% chance of a tornado happening in your town or in your area, basically. So that's what that means. And a hatch means EF2 plus is possible. But anything above EF3 is very unlikely, but never say never in weather. So that's the wind. What's causing this is classical spring setups. You have a dip in the jet stream over the central states. You can see that kind of moving on through. It starts west here and it goes more central. And you have this ridge out east, and you get this warm, moist Gulf air meeting up with this colder Pacific Northwestern Canadian air that's causing that instability in the atmosphere. That's with this classical spring setup. But yeah, it's classical spring setup. In terms of the precipitation, the actual precipitation, you see there are some storms. This would be going on like right now, actually. That fire up in the northern U.S., but around it's just like early afternoon, Wednesday, to get these storms fire up 1,004 millibar low. Those storms fire up. This shows a similar solution to what the SPC would be showing in terms of where the severe storms were located, but maybe a bit more south and to the east. This would be a cold front that comes on through, so I'll show the temperatures later, but it's going to be much colder after the storm, I'll just say that. So you can see that low pressure really curves up to the north, but you can see that line of storm just moves on through. And pay attention to northern Wisconsin, that precipitation actually changes over to snow. So there's enough cold air on the back end that the precipitation is actually able to change over to snow. It doesn't look cold enough to support accumulation. It'd probably be mostly grass accumulation, if anything, especially in the higher elevations. So nothing too impactful, nothing northern Wisconsin can't handle. But yeah, that's the precipitation, and it's a very narrow band of quite heavy thunderstorms. If I look at our temperature, it's a very interesting cold front. And hold on, yeah, that's my bad. It was on northeast US. It's okay though. Okay, so you can see pretty obvious where the front is, and it just goes to the west, and temperatures are going to rapidly drop. If you're in like Iowa, Illinois, Missouri, these temperatures will drop fairly rapidly. You can see here like it's 77 here. It doesn't take that long. It's already at 52. So yeah, the temperatures, it may seem hot at one point, but it will cool down quite significantly. And this also means it's like evening on Wednesday. Let's say like you're in here, it's 80 degrees. You drive like 30 minutes north, it's already 53 degrees. So it's pretty significant, I would say. Yeah, this moves northwest to southeast mainly, but more west-east, but also a bit north and south. So yeah, that's a cold front that's going to come up through afterwards. And then we also have our dew points, which are going to be in the mid-60s for most of the event. And you can see how I'll pull up the eastern U.S. Yeah, they're going to be in the mid-60s for a lot of the event. And that will be enough to support some severe thunderstorms. Is enough to support severe thunderstorms, I should say. But it isn't crazy, but it's decent. Yeah, it's pretty good. The air is pretty moist. That means if the dew point is at 60, but there will be some dry air intruding, and that's really going to hurt. It's one of the main things actually that's hurting the potential of this system. So this is total precip, And you can see that this is interesting. This will not be snow. Most of this will not be snow anyway. In areas of northeastern Iowa, southwestern Wisconsin, and other areas such as eastern Nebraska, some reason the border between Mississippi and Alabama. We might get an isolated 2 to 4 inches. It depends exactly where the heaviest rain is set up. But honestly, this could happen anywhere. But right now, it's showing it in the more northern parts of the system. But we do get sections of this would be like 1.5 inches of rain. So this could have some flash flooding implications with it too. Um, this doesn't look that impressive. This HRR rain doesn't look that impressive. There is some impressive rain, but the storms don't look too impressive. I'll show like the Cape later, but that doesn't look impressive. This is the service-based Cape. Nothing much. This is before our system though. And if we move to our system, it's nothing crazy. I mean, you have Cape levels almost 2,000 joules per kilogram. Not quite though. Maybe you get it more north, but I mean, I don't know. And this is like in the 10% risk, and it's only 800. It's barely enough instability to support even like a thunderstorm, let alone a very severe one. So these Cape levels really aren't impressive. If you go to our scale, it's like not even, it's like on the low end of the scale. So yeah, I don't. The SPC maybe is seeing something we're not. Maybe they have a different model. I don't really know. But yeah, this Cape is not impressive whatsoever. I mean, this is not. When you see 10% hatched and moderate risk or enhanced risk, you don't usually see this Cape. So this is kind of interesting. But there's other factors. I played with the wind shear is pretty good. The supercell composite is also pretty good. So it's not just Cape, but the Cape is not impressive whatsoever. The SPC, they have their own thing. They know best. You don't want to challenge them. You don't want to say like they're wrong, but this does feel kind of weird. It's also a bit more Western than the SPC outlook, which is interesting. But yeah, and this kind of falls apart quite quickly too. You can see that there's more Cape in the Gulf, and this might be a severe weather event on Halloween. This is something that has a marginal risk right now. And that's decent Cape, but I'll probably talk about that in another video. But that has decent Cape, similar to this one, but the difference is this one is a moderate risk. So the Cape isn't too impressive. This is like Cape you would see maybe in a marginal risk. I would say maybe a slight risk actually. This could be a slight risk. But that's the Cape. Really nothing too impressive. The shear is interesting. The shear really gets going in our tornado risk areas. You can see 61, 59, so it's decent shear. The data I'm showing the HRR suggests maybe it should be pushed a little bit to the north and maybe a bit to the west. But, we'll have to see. You do have pretty significant shear in the tri-state area. We'll have to see though, they might not. And there's other factors that go into it, obviously, but shear is one of the main ones. And the shear kind of collapses, you can see here, and then kind of reignites, almost, you could say. And I think that's what's driving them to push it more south and east. But I think maybe there should be another tornado risk or a higher one up here, but we'll have to see. But yeah, 45 knot per hour wind shear in northern Missouri. It really starts to get its act together. And eventually it's going to dissipate. And there won't be much of a storm effect because that lower Cape levels too. So you need wind shear and Cape. So these wind shear levels still look pretty good, but the Cape isn't good. So you can't really have severe storms anyway. So that's the wind shear. It looks better. Then the Cape, those also make a good support some tornadoes. Maybe even some severe tornadoes. EF2 is why I say severe. I mean, EF2 is not like EF3s or anything like that. But yeah, that's the shear. This is also a classical May setup, I would say, with that cold air coming from Canada, that warm Gulf air. coming up, and the air will be moist, but there will soon be some dry air. That's the main thing that's really keeping this event from becoming a big event. Is that dry air really impeding the instability in the atmosphere, and that's lowering the CAPE levels, just like instability. CAPE is basically instability and energy. Oh, that was a horrible voice crack. Oh no. Anyways, supercell composite. Um, it gets going a little bit, and this won't be a severe weather event. This is maybe in the risk, but it's not our main one. It gets going a little bit on Wednesday morning, and it really starts to fire up. And this is what they're looking at when they decide to put that 10% hatch as a supercell composite. And this is the only thing, and this shows it being more southern, shows the opposite of the wind shear actually, which I think is interesting, but shows it being more southern. But if you ask me, this is what they see, but this doesn't make sense to the to where the risks are. So if I had to guess, they're saying the supercell composite, and they think, okay, there's a potential for some risk of severe weather, and there's higher wind shear to the north. So we think they're getting the supercell, the amount of supercells right, the supercell composite right. We don't think they're getting the location right. That would be my theory at this point. But again, anything can happen. So even though it may seem like, oh, the 10% hatch isn't, uh, it's not good to put there. It should be 10% no hatch, maybe 5% no hatch. Anything can happen, and they've clearly done it for a reason.